So today we're going to discuss the idea of a meta-Ferris wheel. So let's make sure we understand what a meta-Ferris wheel is. The black circle represents a big Ferris wheel. We say it's 44 feet in diameter, indicated here, right? And normally with the Ferris wheel, you get on, you stay in one part on the circumference of the circle as it moves around, the big wheel that is. But now what we're saying is this red Ferris wheel is sort of nested within the big Ferris wheel. So like the big Ferris wheel moves, as the big Ferris wheel moves, the little Ferris wheel is moving also. And I've indicated some information. So for example, the big Ferris wheel moves at 20 minutes per revolution. The little Ferris wheel is 5 minutes per revolution. So I think it would be kind of neat to consider what this thing looks like after certain amounts of time have gone by, right? So let's consider what would happen after 5 minutes. So after 5 minutes, we know that the big Ferris wheel would have rotated 1/4 of a rotation, and that the little Ferris wheel would have gone around completely. So what would have happened is the little Ferris wheel now would end up here on top, and your location would be right there on the top of the little Ferris wheel. That's where you'd be, because it rotated all the way around in 5 minutes. Okay? All right. Let's consider what happens after 10 minutes. After 10 minutes, we'd be halfway around the big Ferris wheel, and going from 5 minutes to 10 minutes is another 5 minutes of time gone by. So the little Ferris wheel, again, went around completely. So here we are at t equals 10 minutes. And then if we go to t equals 15 minutes over here, that's where t equals 15 minutes, the big Ferris wheel was 3/4 way around. The little Ferris wheel again made it a complete rotation to the top. So here we are again at t equals 15. So if you look at this, for the time being, it looks like by having the little Ferris wheel on the biggest Ferris wheel, that every point is now 7 feet higher than it used to be. Okay? And at least for these 4 times, that's true. Okay? But consider what happens if you go to 2.5 minutes. So we'll go to a new picture here, so I don't want to get too busy. Okay? Let's consider that. So after 2.5 minutes, we would have gone 1/8 of the way around the big Ferris wheel. And then the little Ferris wheel, remember, it takes 5 minutes to go around the little Ferris wheel. The little Ferris wheel would have rotated half a rotation. So you'd be at the bottom of the little Ferris wheel. So there's t equals 2.5 minutes, right? And now what you can tell is, here's where things get a little strange. At this point here, back when t was equal to 0, we were 7 feet above where we would have been on the big Ferris wheel. But now at t equals 2.5 minutes, we're 7 feet below where we would have been on the big Ferris wheel. So here's what's not true. In the previous picture, we started to suspect maybe that the whole Ferris wheel just got shifted up by 7 feet. But this picture tells us that that's not the case. Okay? All right. So let's start to think about it for a little bit, and I bet you it'll get clearer for you in a second. So what I'm going to ask us to do is just think about, for the time being, just think about the little Ferris wheel. And imagine we were going to find the equation of just that little Ferris wheel. So that would equal h of t equals, and if we think about the little Ferris wheel, think about where we're starting. We're starting here at the top. All right, so we're going to make a graph just for the little Ferris wheel. So here's our picture. It starts at the top of the Ferris wheel at some height. I don't know yet. Well, actually, maybe do I know that height? I think I kind of do, right? All right, but we'll get to that. Just the little Ferris wheel, so we'll say that. Then as it rotates, after 2.5, actually less than that, it's 5 minutes all the way around. So this point down here would be t equals 2.5 minutes. This point right here is t equals 1.25 minutes. And this point is t equals 3.75 minutes. So what can we tell? Our height starts off high. It goes to the midline. Then it goes low, back to the midline, and back up. So the graph looks something like this. Now notice I'm ignoring all the numbers for now. Okay? So that's what the little Ferris wheel does. Well, that's a cosine graph. Right? So we can write that down. Cosine blank plus blank blank h of t equals. Okay. Now, I claim that we know that number right there. That's your distance above and below the midline that you go. Now, I haven't said what the midline is yet. We're going to leave that alone for now. So the midline's a mystery. But we do know that distance and that distance. Okay? Let's go back to the Ferris wheel. If here's the midline of the Ferris wheel, then what's that distance there? It's 7. So this is a 7 in front. Okay? Now we also know we can get, this is called the amplitude, by the way. We also know the number that goes there. Because we know the period of the little Ferris wheel is 5 minutes. So 5 minutes equals 2 pi over b. So we can solve that. 5b equals 2 pi. And then we want to get b alone, so we'll divide. We'll get b equals 2 pi over 5. And there you go. So now you have the frequency of this little Ferris wheel. So that's not going to quite fit in there. I'll write it again. H of t equals 7 cosine 2 pi over 5 t plus, and then I'd love to have a midline. But here comes the fun part of the meta Ferris wheel. So let's give this a little thought. Let's go back to our picture. If we look at just the red Ferris wheel, we think about this situation. Looking at the midline of the little red Ferris wheel, you should ask yourself this question. Does it stay the same the whole time during the Ferris wheel? Is the midline always in the same location? So the key thing to realize is that this blue dotted midline actually changes as the big Ferris wheel rotates. And the height of that midline, right, is exactly the equation of the big Ferris wheel, which we can find. So let's go do that. So I'm going to actually just going to go down here. I'm going to write in here just so I know. Instead of writing midline, we're going to write big Ferris wheel. Because that's what's going to go there, the equation of the big Ferris wheel. Okay? All right, so the big Ferris wheel, let's look at its properties, right? The big Ferris wheel at t equals 0 is located in that position. This is going to be t equals 5 minutes, t equals 10 minutes, t equals 15, and then we're back to t equals 20. So what can we say about the big Ferris wheel? H of t equals, if we think about it, it starts, the big Ferris wheel has its own midline right here. I'll do that in green so we don't lose track of it. There's the midline of the big Ferris wheel. You should ask yourself, does that midline change? And the answer is no. The big Ferris wheel's midline is always at the same height. It doesn't change. Okay? The little Ferris wheel's midline changes because the middle Ferris wheel's hooked to the circumference of the circle as it moves around. Okay? So this big Ferris wheel starts on its midline, so it has to be a sine graph. It goes up first. So this graph will end up looking like this. So it's a sine graph. So it's going to be sine blank plus blank. Well, the midline of the big Ferris wheel is 10 plus the radius, which is 22, so it's going to be 32. The distance above and below the midline that it moves is the radius of the big Ferris wheel, so that's 22. And then lastly, in here, you're going to have t, and we got to get the number that goes there, so we'll do 2 pi, I'm sorry, not that. We'll do 20 minutes equals 2 pi over b, and I'm going to get 20b equals 2 pi. So I'll divide, so I think we're going to get b equals pi over 10. So that's the equation of the big Ferris wheel, and also the equation of the midline of the little Ferris wheel. So now we're ready to put it together and get an equation. So we know that for our new Ferris wheel ride, h of t equals, it's 7 cosine 2 pi over 5t plus the equation of the big Ferris wheel, which we said was 22 sine pi over 10t plus 32. And the key idea for keeping these questions like sorted in your mind is to realize that the meta Ferris wheel is just a Ferris wheel problem with a variable midline. That's what it is. Okay. Let's look at the graph of this thing. So let's go to our calculator. Let's look at the graph of this thing. We'll go to y equals. Now make sure your calculator's in radian mode, otherwise these graphs aren't going to work. Okay. So we had 7 cosine of 2 pi divided by 5 x, close parenthesis, plus, and here's where we would normally have a midline, but instead we have the equation of the big Ferris wheel. So remember, it was 7 cosine 2 pi over 5x plus 22 sine pi divided by 10x, close parentheses, plus 32. So before I just hit graph, I should really think about my window. All right, so for the window, for x min, 0 is reasonable. We start at 0 minutes. This ride's going to take 20 minutes to get around, okay? And the only thing we're going to worry about is sort of y max. What's the highest y value we reach? So if we look back through our pictures, we'll see, we'll go back to this picture, it's the first one. We can see that the highest point is up here. That happens at t equals 5 minutes. And it looks like you're going to have 10 feet plus the 44, right, plus another 5. It's 49.59. So for our y max, I'm just going to go with like 70, something bigger than 59. Let's give it a look. Press graph. And here it goes. And look at that. There's our Ferris wheel ride. I'd like to make sense of this ride. Now, it doesn't look like the other Ferris wheel rides. The other Ferris wheels had that nice midline going through it. Okay? But remember what we said earlier, right? We said that the little Ferris wheel is just like a Ferris wheel equation with a variable midline. And the variable midline was the equation of the big Ferris wheel. So I'm going to go to y2 now, and I'm just going to put in the equation of that big Ferris wheel. So 22 sine pi divided by 10x, close parenthesis, plus 32. So what I did was, in y2, I put the equation of the big Ferris wheel. Now the reason I did that is the big Ferris wheel represents the midline, right, of the little Ferris wheel. Now watch what happens. Press graph. Okay? And we get something very neat. So you look at this for a second and say, that doesn't make a lot of sense. But hold on. Let's grab this picture here and take it back to my notes for a second. And let's take a look at this. So in red, the red represents the ride that you'd experience when you went on this meta Ferris wheel. The green is the equation of the big Ferris wheel. And what I want you to realize is, I want you to imagine that the green line, that we could pull that straight. Imagine the green line was like a piece of string. If I had a better animation technique, I would do that. But if you notice, relative to the green line, the red graph is just like a cosine graph, going above and below it. Essentially what I've done is, I've taken a graph that looked like this, and it had a midline like that, and I've curved the midline. And by curving the midline, I made the graph follow a different midline that varies with time. That's what I did.